All right, so here we are on Module 1, Lesson 5, Equivalent Ratios. And the essential questions for today have to do with, well, for any two ratios, how do we know whether they are equivalent? Great word, by the way. And why is it helpful to find equivalent ratios? All right, so let's deal with these guys here. Well, let's start off with what is an equivalent ratio. Okay, an equivalent ratio is what I like to call the chocolate milk always tastes the same, or the iced tea always tastes the same, or the lemonade always tastes the same. And what I mean by that is, if you were to make a mix of make up a batch of iced tea, right? So let's say for every cup of water you're going to use, let's see, for every 1 cup of water, let's say you need 2 scoops, right? You need 2 scoops. Now that it sounds like it's going to be a little bit thick, but maybe you like it that way. I don't know. The deal is, listen, this is a rather small sampling of iced tea, but what if you wanted to make a larger batch? Let's say you wanted to double the amount of water. Well, if you double the amount of water, well, you're then going to need to double the amount of scoops, that kind of thing. Well, let's just say that you wanted to make 10 cups. What we do now is use the information, use the chart to say, hey, what happens when we had a 1 to 2 ratio? What do we do to that 1, or what do we do to the water now that we want to use 10 cups? Well, the deal is we multiply by 10. Well, in order for the iced tea to taste exactly the same, we're going to need to do the exact same thing to the other side. So if we are multiplying the amount of cups by 10, we now need to multiply the amount of scoops by 10. Okay, so 2 times 10 gives me 20. That way we know that the iced tea will always taste the same. Okay? And that's the deal with the equivalency. Now, why is it helpful to find equivalent ratios? Well, exactly that reason. We want to make sure we are consistent with whatever it is we are doing. Okay, so let's put some of this into practice here a little bit. On page, what page is this here? Right, there's a page here somewhere. On page 49. All right, so let's start off on page 49. Let me put that in there. On page 49, we have a bouquet of roses and daisies. There are a total of 105 flowers. Now, here's our ratio. For every 2 roses, we have 3 daisies. Let me build a little chart right here so we can see what's up. So here are our roses. Here are the daisies. Okay, and that's a 2 to 3 deal. All right, now these are all flowers. The roses are flowers, the daisies are flowers, and we have 105 total flowers. Well, in this bouquet, the initial one here, we have a total of five flowers. Now you can, if you want, start doubling everything up. Turn a 2 into 4, right? Multiply by 2, multiply by 2, and start building. And now we have 10 total flowers, and keep going until you get 105. Another option is just to keep drawing all these flowers, right? So you have the flower there, you have a flower there, and that's the red one, and and then you do the 3 daisies down here. I think those are the daisies, and you keep drawing until you have a total, right? 5, 10, and you just keep going. To me, that's all kind of crazy. What I like to do is go right into a tape diagram. Best way to tackle this. Okay, watch this. So if you have the roses and we have our daisies, right? Tape diagram is perfect for this. Okay, get a little dotted line cruising down. We plug in our ratio right here. So some people like to call this a given ratio. Okay, that's a 2 for the roses. So for every 2 roses, we have 3 daisies like that. Okay, there's our given ratio. Now watch what happens here. This is kind of cool. Right now, if we count up just the boxes, we have 5 boxes, right? So if I do this, if I bracket the whole thing, right, we have 5 boxes. But watch what happens here. If I take this particular total right there, 105, because that's 105 flowers, and we bracket everything under the umbrella of the 105 flowers, that means that we have 5 units, right? 5 boxes, 5 units, all of equal size, that total 105. All I have to do now is take that 105, divide it by those 5 units. Okay, that's a 0, that's a 2, that's a 10. We bring down that 5, that goes once, for 5, nothing left, 21. Now that 21 is a very important number. Okay, we call that a constant. And what that represents, that should be an A right there, sorry. And what that represents is the value of each of these boxes, right? Now, hopefully you can see what I see. All we have to do now to find our totals, okay, is to add things up or multiply. So the top for the roses, we have 21 times 2, right? So that gives us 42. And down on the bottom here, we have a 21 times 3 because there are 3 boxes, and that gives us 63. And there we have it, okay? Just like that, we can now find our missing ratio. And the 42, right, to the 63 is equivalent to the 2 to 3 because, well, if I made a chart around the thing, right, if I built a chart, we know that the iced tea would always taste the same because if I multiplied each by 21, right, times 21 times 21, there we go. And since these values are the same, right, my multiplicative value is the same, our two ratios are equivalent. Okay. Okay, so what else do they want here? How many roses are in the bouquet? How many daisies are in the bouquet? Okay, so there it is. So we had that. So roses equals 42. The daisies equals 63. Cool. All right. That's pretty neat. Let's see what's happening here. This is kind of neat. All right, so write two ratios, one that is equivalent to this guy and one that is not equivalent to that ratio. Okay, well, let's make one that is equivalent. That's not so bad. Okay, so we have a 3 to 5. And all I need to do is pick a constant. What would you like to multiply by? As long as you multiply both sides of this, or both values, by the same value, we're good to go. So how about a times 3? How about a times 3? 3 times 3 gives me 9. 5 times 3 gives me 15. It's a terrible 15, sorry. But those two are now equivalent because they share that common multiplicative value. So a 3 to 5 is equivalent to the 9 to 15. Now, if they want one that's not equivalent at all I now need to do is multiply by two different values, right? So if I have a 3 to 5, maybe I multiply this guy by 2. Maybe I multiply this guy by 4. Okay, and I would have a 6 over here, and I would have a 20 over there, and there's no way that those guys are equivalent. Okay, the iced tea, the chocolate milk, the lemonade will not taste the same at all. All right, there it is. Okay, so these guys are equivalent. These guys, right, are not equivalent, like that. Okay, all right, let's see what else. Let's cruise down to the practice. Let's see if there's anything fun in there. There's a lot in here. Exit ticket, the recap. A lot of great stuff in here. Practice. Let's take care of one of these things. Okay, so this is page, what, 57? 57. So page 57. All right, so in a rice recipe, a ratio that relates to the number of cups of water to the number of cups of rice, 2 to 1. Okay, so we have a 2 to 1 ratio. I need a tape diagram. Okay, so they want a tape diagram, piece of cake, maybe. Let's see what's up. So water, those are my 2 units, well, one of the units, and the rice is the other unit. Okay, rice. Okay, put my little arrows. I love to line things up. Make sure everything's nice. And a 2 to 1. Okay, so for every 2 cups of water, I put another dotted line just to line things up. To 1 cup of rice. Okay, and that's the deal, right? So that's all they wanted there. Just draw the tape diagram. Okay, so how many cups of water should be mixed with 4 cups of rice? Oh, okay. I'm going to make a little abridged version here. Water, rice. So I guess I should just use that diagram up above. But I just have so much fun writing these, drawing things. So 4 cups of rice. If I have 4 cups of rice, I can put that 4 right in there, right? Because that represents the total of rice. There it is, 4 cups of rice. Well, if that bugger is 4, well, these guys are 4 also. Okay, add them up, and you get 8. Okay, so 8 cups of water, right? So water equals 8 cups. Okay, and the rice equals the 4 cups because that's one they gave us. Okay, those guys are equivalent. Okay, so a 2 to 1 ratio is equivalent to an 8 to 4 ratio. Let's see what else we have here. Should we do another one or are we okay? Let's see. Those 2's look like they're out of whack here a little bit. Let's see. The tape diagram shows the ratio of 4 to 3 is equivalent to an 8 to 6. Hmm. Yeah, well, you know what? I'll just do a piece of this. Sure, that does make sense, right? Because look at this. 2, 4, 6, 8 down there, 6 down there, and the initial ratio had 4 boxes and the other one had 3. So, yeah, this is looking pretty good. All right, folks. So that's the deal with lesson 5. Hope you had fun with that. Okay. Take care. So long. Bye-bye.